Hi, this tutorial covers cautions about hypothesis tests. Alright, so let's start with a situation here. So suppose a high school principal wants to reduce the passing time between classes from 6 minutes to 5 minutes. The principal wants to test the mean number of minutes it takes the student population to travel from class to class. He will use the following hypotheses. So his null hypothesis is that mu is equal to 5. His alternate hypothesis is mu is less than 5. Okay, so what he wants to do is have evidence for the alternative hypothesis to show that it really takes students less than 5 minutes, so that they really only need 5 minutes to get to class instead of the 6 minutes. All right, so he selected 20 teachers to walk from class to class. Based on the sample mean and the sample standard deviation obtained from the teachers, the principal found a significant p-value. Okay, does he have evidence for the alternative hypothesis? Okay, so he's saying that he got a small p-value, but I would say the answer to this question is no. Okay, and for the reason of the conditions of the hypothesis test. So in this case, I would say that the conditions of this test were not met. Okay, it's mainly based on this convenience sample. Remember, any hypothesis test needs to be based on a random sample. Okay, he had a convenience sample here, which introduces bias into the hypothesis test. Okay, and in this case, it's probably a pretty intentional bias. He's picking teachers to walk from class to class. Teachers will probably walk faster, won't have anyone to talk to in the hallway, probably know a faster way to get from class to class. So this convenience sample is certainly not a simple random sample. So no, he does not have evidence for the alternative hypothesis. Okay, so caution needs to be taken when using hypothesis tests. If the conditions are not met for a given test, the conclusions might not be valid. All right, so let's take a look at same situation, but now suppose instead the principal selects a random sample of 50 students. All right, so it is random this time. Now using the sample mean and sample standard deviation, the principal calculated a p-value of 0.08. Okay. After calculating the p-value, he picked a significance level of 0.1. Does he have evidence for the alternative hypothesis? Well, it would seem that based on his level of alpha, his significance level, and his p-value is smaller, so generally that allows us to reject the null and give evidence for the alternative hypothesis. Okay, the one flaw in his thinking here is that he picked the significance level after calculating the p-value. Okay, that is something that you do want to avoid. Okay, the level of significance does need to be picked ahead of time. Okay, to try to account for the different types of errors that can occur. But in this case, it's irresponsible to pick the p-value, or excuse me, pick the level of significance value after calculating the p-value. Okay, because if he would have picked a p-value of 0.05 or 0.01 ahead of time, this would not be a significant p-value. All right, so if the test is run and then the significance level is picked, the researcher is being dishonest in applying that the significance level was chosen independently. Okay, so the significance level does need to be chosen independently of the significance level being or the p-value being calculated. All right, we have another issue in hypothesis testing, not really related to the principal example, but if we carry out many different kinds of hypothesis tests with a population that we have data on, we have to keep in mind that the sampling error means that at the 5% significance level, we will get statistical significance just by chance 1 out of 20 times. This is sometimes called the multiple testing problem. Okay, so this may happen, especially if you're taking frequent observations of some sort of phenomenon via computer. Okay, it might the computer may have the functionality to do hypothesis test after hypothesis test after hypothesis test. Okay, we need to be a little bit careful because using even a pretty small significance level, you are still going to get a false positive result 1 out of every 20 times. Okay, so especially if you're running many hypothesis tests, you might end up getting a lot of false positive tests in here. Okay, so that is an issue that we need to make sure we are wary of. So the multiple testing problem is a problem that occurs when multiple hypothesis tests are performed on a population, leading to an increase in false positive tests. All right, now to avoid most of these issues with hypothesis testing, it is important to have a reasonable model of the population and make reasonable hypotheses before the test is conducted. Okay, so a lot of times, most of your issues can be avoided if you kind of figure out what your population looks like ahead of time and then make some reasonable hypotheses. All right, that has been the tutorial on cautions about hypothesis testing. Thanks for watching.